My name is Parth Vaizapurkar. My roll number is Q30 and I am going to discuss the basic principle of three-phase induction motor and the working of three-phase induction motor. First, going towards the working, we should consider the difference between the three-phase induction motor and DC motor. The first one is the short air gap. The air gap present in three-phase induction motor is a short. What is mean by the air gap? The distance between the stator and rotor is very less in case of three-phase induction motor. Second one is no poles are present in the three-phase induction motor. Third one is there is absence of commutator in three-phase induction motor, and the another, that is last one, is speed limitation. Three-phase induction motor have their own speed limitation, and whereas the DC motor has not its speed limitation. So now we will go towards the construction of three-phase induction motor.
Start.
Going towards the construction of three-phase induction motor, there are basically two main components of three-phase induction motor. One is the stator, which is the outer surface of the motor, and it is a stationary one. And the second one is the rotor, which rotates uniformly in the three-phase induction motor. There are two types of rotor. One is a slip ring type of rotor and another one is a squirrel cage type of rotor. In slip rings, there are the three open conductors present, which are connected to the stator with the help of brushes. What the brushes do, it connect the rotor to the stator. In case of the squirrel cage, the structure of rotor is like this. These conductors are short-circuited with the help of end rings present. Now we will go towards the working of three-phase induction motor.
Start.
In the working of three-phase induction motor, here the input of three-phase is connected to the stator one. Here the stator winding is present. This stator winding produces rotating magnetic field, which is denoted as RMF, such that in the downward direction, and the magnetic field is rotating, so it rotates clockwise direction. That is, we have assumed it. One thing to notate that there are no such poles present in the three-phase induction motor, but to understand the concept of rotating magnetic field, we can assume that there are north pole and south pole present near the three-phase induction motor, and which is these poles are rotating in the clockwise direction. So now we know that the conductor placed in rotating magnetic field, or the change in magnetic field, it produces electromagnetic forces, EMF, and due to the production of EMF, current is developed in case of conductors.
Go.
Using Fleming's right hand rule, we can determine the direction of induced current. See, what the Fleming's right hand rule states, that when we outstretch the three fingers of our right hand such that the thumb, first finger and middle finger are kept mutually perpendicular to each other, and then if the thumb is indicating the direction of motion of conductor and first finger is indicating the direction of EMF, then the middle finger indicates the direction of induced current. See, in this field, in this case, the direction of motion of conductor is in the anti-clockwise direction, because the rotating magnetic field is rotating in clockwise direction and the conductor is stationary. So we can assume that the conductor is rotating in anti-clockwise direction, assuming that the rotating magnetic field is stationary. So the direction of a conductor is in left, and the direction of the magnetic field is in downward direction. So the induced EMF is towards us, that is the outward from the board.
Start.
So we have denoted the current by dotted dots in this conductor. As we go towards the downward direction, the current is going towards the towards the plane, that is inside the plane.
1. Go.
We know that the current carrying conductor placed in changing magnetic field experience a force or experience a torque. The direction of force or torque is determined with the help of Fleming's left hand rule, which is used to detect rotating action. What is the basically Fleming's left hand rule states that when we keep the first three fingers of our left hand mutually perpendicular to each other, and at that time if the first finger is indicating the direction of the magnetic field and middle finger is indicating the direction of current, then the thumb indicates the force experienced by it. Now we will see how the Fleming's left hand rule is applicable in case of three-phase induction motor. See, the direction of the rotating magnetic field is downward, and the current that is we have spotted with the help of dot, it is coming outward. When we place our first finger in downward direction and the middle finger in outward direction, then the thumb indicates the direction of force experienced by the conductor. So the direction is in right side, that is the rotor or the conductor is moving in clockwise direction. So by this we have came to the conclusion that the direction of the rotating magnetic field and the direction of the rotor, that is conductor, is in the same direction. We know that the speed of rotating magnetic field, that is synchronous speed, it is denoted as ns, which is equal to the 120 into f divided by p. What is f here? F here is frequency and the p is the number of poles present in the three-phase induction motor. Ns, that is synchronous speed, is the speed of rotating magnetic field, and the nr, which is denoted here, it is the speed of rotor. When the ns is equal to the nr, that is conductor is moving with the same speed that of rotating magnetic field, the change in magnetic field gets zero. So the force experienced by the conductor becomes zero. So we have to know that the speed of rotating magnetic field and the speed of the rotor, that is conductor, can never be equal. So when the ns is equal to nr, the torque is zero, so that the motor gets stopped. So we have to know that speed of rotor is always less than speed of synchronous speed, that is speed of rotating magnetic field, for settled down condition. Now we will go to the last concept of three-phase induction motor, that is slip. What is meant by slip? Slip is the nothing but relative change of speed of rotating magnetic field and speed of rotor. The formula of speed is ns minus nr divided by ns into 100. That is the percentage change in the speed of rotating rotor to the stator. So by this we have concluded that the three-phase induction motor working and the construction of the three-phase induction motor. Why the name three-phase induction motor given? That is basically this motor is rotated with the help of the induction principle. It is not directly supply is not directly given to the rotor. Supply is given to the stator, and the induced EMF is induced in stator rotor, and it rotates. So the input is electrical and the output which is observed at the shaft is mechanical. So this is the working of three-phase induction motor. Thank you. My name is Parth Vaizapurkar from Q Division and VIT College, roll number Q30.